Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask an Engineer. It's me, Lady Ada, the engineer, with me, Mr. Lady Ada on camera control. Thank you. We're both very goth today. We're broadcasting live from downtown Manhattan. That's where we have the Adafruit headquarters. We do all of our kitting and shipping and packaging and coding, and we do assembly. We do all sorts of stuff there. But right now we're gonna hang out with you guys for like about an hour. Me, Mr. Lady Ada, and we got a full packed show of goodies to show you
We got to
all.
leave a little early, but the show goes on, so we're just going to condense the show for all the important things that you know and love and want to watch each week.
It's gonna be like a neutron ball.
Yeah.
Of like Adafruit.
Yeah.
Okay, tell us about tonight's show.
On tonight's show, the code is springy, 10% off in the Adafruit store, all the way up to 11:59 p.m. Use it in support an open source hardware company, manufacturing, electronics in New York City, USA. Talk about some of our live shows. Got a JP's product pick of the week highlight, some made in New York City factory footage, a 3D printing speed up. We've got Eye on MPI. This week is Rich Tech, brought to you by DigiKey. Thank you, DigiKey. We got some top secret previews of some new Trinkies, some new products. We can answer your questions over on Discord. We can join like all 33,000 of us, adafruit.it/discord, discord.gg/adafruit. We're going to talk about some free stuff, all the things you can get in addition to the discount code, all that and more on Ask an Engineer.
Yay!
Yeah, okay. So don't forget code Springy. And what do they get?
Bringing into spring. Okay.
Springy, what do they get when they start putting stuff in their cart?
Yes, when you order from adafruit.com, we give you free stuff. Like if you order $99 or more, we'll give you this beautiful gold and black coaster with the Adafruit logo and some little rubber bumpers. It's great for putting your hot or cold drink on it, and it will keep your desk nice and clean. And we're still doing our $149 or more giveaway for the KB2040. It's a Pro Micro Pinout compatible microcontroller featuring the Raspberry Pi RP2040 chip with flash memory, buttons, and NeoPixel USB-C encapsulated pads. So it's a great little microcontroller board with a nice powerful chip, a good upgrade to the Pro Micro. $199 or more free UPS ground shipping in the continental United States. And last but not least, for $299 or more orders, we give you a free Circuit Playground Express. It's round and colorful and has sensors and buttons, and it works with Arduino, Code.org, CS Discoveries, MakeCode, CircuitPython, and many other languages. It's a great way to get started with programming or electronics without any other tools.
Okay, we do a bunch of live shows. We just got off the air. Do check out all the places we post our videos, all the places such as YouTube, Twitch, Facebook, Instagram, Threads, you name it.
Yeah.
Thank you, JP, for doing show and tell. On Sundays, we do From the Desk of Lady Ada and The Great Search. Watch that there, too. And on Tuesdays, we do JP's product pick of the week, and we have a highlight of this week. Take it away, JP.
It is the SHT41 temperature and humidity Trinky. It has a quick, easy monitoring solution. And you can see here, this just slides right in. And that's a thick enough board that it actually stays in there quite nicely. Here you can see every 2 seconds I have it logging the temperature in both Celsius and Fahrenheit. So it's about 78 degrees in here right now, and humidity is at about 29%. I can probably skew that a bit either by just touching the sensor. That'll probably warm it up a bit. Oh, it's cooling it. I'm cooler than I'm cooler than the air. You can see the humidity jumped up there just because of some perspiration on my finger, or if I blow on it. So if we give it a little warm, hot breath there, we got it up to 83 degrees and about 80% humidity. The SHT41 temperature and humidity Trinky.
Okay, and don't forget on Thursday, you can watch JP's workshop. On Friday, deep dive with Scott.
With Scott, yeah, too.
Or 5 p.m. Eastern. And if Scott's not there, it's deep dive with Tim. But usually it's Scott now. So do tune in on Fridays. Okay, let's do some Python on hardware time. There's a couple things you want to talk about this week.
Yep.
Yeah, you wanted to talk about. We have 903 released. Do check out the
Bug
latest.
fixes.
Yeah. And then there's expressive chip news.
Well, sign up if you want to get notified when we have this ESP32C6 feather. It's still in prototype phase. That's why it's green. But, you know, one day it'll not be green. It'll be black. And that's how you know it's released. And then you'll get notified when it's in stock. Another thing that I thought was kind of cool is we saw a preview like almost a year ago about the ESP32P4, which is like a very powerful processor. You want to scroll down a little bit?
Yeah.
So this is it's so it's interesting. It doesn't have Wi-Fi. Oh no, it does have Wi-Fi. It wasn't clear at the time. So it's Wi-Fi, but it has like dual core 400 megahertz processors. I don't know if it's in Tensilica or RISC-V. It's got like CSI, DSI support, HDMI, a lot of display, very serious display stuff, which they've been sort of practicing a little bit with the S3. The P4 is really cool, very big too. 32K of built-in SRAM, and of course PSRAM can be added. There's 16 kilobytes of ROM. I think that's just to run it. Oh yeah, there you go. Up to 64 megabytes of PSRAM, built-in 768 kilobytes of SRAM, and then 32 kilobytes of low power SRAM. And they're really good at low power stuff, FPU, DSP. But yeah, basically display stuff is where it seems to be at, built-in decoders and stuff. So yeah, obviously we're interested in the chip. When it comes out, we'd love to add CircuitPython support.
Yeah. I got a question for you. So they have independent in deep sleep. So when a chip maker says something like this, how would they handle that when they say independent? Like what are they doing?
That's a good question.
What are they doing to say independent? Is
I've
it
seen
another chip that does it? That's like waking up stuff. Is it a watchdog, as they say?
They could have a low power chip like a RISC-V core, which they've done in a couple chips so far. They've had the main core and then a very, very low power RISC-V core. So there could be some sub-processor that is like in deep sleep of the main processor. It is doing little tasks like checking for voltage or communicating over I2C or checking for pins and stuff. I'm assuming that's what that means. I don't know though.
Yeah, that'd be interesting. As someone, Todd mentioned the chat that they're keeping the ESP32 branded, which they don't need to, but like everyone knows what that is. So that makes a lot of sense.
Espresso. I mean, like it, yeah, it's a little confusing when people say ESP32. It's like, well, do you mean the classic or do you mean the S2 or the S3? But it is a very strong brand. And there probably is something to that name that means something. It could be that's the Tensilica 32-bit family.
Yeah.
I don't know. Yeah, I mean, like they do have the I think they did ESP8225. But
Well, for tech naming, there's Windows. MTO in the chat says, .NET. There's a lot of terms. I remember I did work with Sony a long time ago. They had Memory Stick Duo Pro Plus, Memory Stick Duo Pro Extreme. It kind of got.
Yeah, it's challenging because on one hand, it's like, you want to lean on a good name. On the other hand, it can be confusing. But, like the AVR series I got now had, still making AVRs.
Yeah.
And they've changed quite a bit.
So I'm kind of curious about how they're going to do independent deep sleep. Like, is it another chip? What is that thing? Like, what is it?
Yeah, the deep sleep's very interesting. They're very innovative on that.
Yeah. Okay. So what else did you want to talk about?
The other thing that's kind of cool is ToddBot did these cool mini videos about using. Oh, go back. Click on the Mastodon link. So these neat videos. I don't know what's gonna happen.
Yeah. Oh, look, it
Okay.
worked. Okay.
You can play the video. So we added this thing called bitmap filter for the camera, and then like I kind of like never got to the projects I wanted to do with it. But I like that he's like revitalizing this thing, which allows you to it basically allows you to set up a kernel for a convolution filter that you can then apply to a bitmap. And I believe we actually did 3 by 3 by 3, so like true RGB cubic filter, so you could actually like have different channels affect other channels. And I thought this would be kind of cool because you could like maybe do like some photography filters on it. But like I said, I never got to it. So it's kind of interesting to see that he's like, oh, like I'm doing like process, like I'm, kind of processing like art. It'd be cool to have Pi processing, be like, a Python version of processing, for making these kind of cool, funky filters.
That's cool. And yeah, thanks, Jepler, for bitmap filter.
Yes.
Okay. And is there anything else you want to talk about?
That's it. I think that's a lot.
Yeah.
There's
So-
more. The newsletter.
Tons. Yeah.
Well-
Tons. And special thanks to Anne, our editor in chief, for the newsletter. We deliver this every single week to your inbox, and you can get that at adafruitdaily.com. We keep it separate from your store account because we do not spam. Okay, some open source hardware news. First up, we're a sponsor of the Open Hardware Summit. They posted up the sponsor list and more. And
do you know how many open source hardware contribution certifications we have?
At the time, it was 740, but I think it's actually like 760 now or something like that.
Yeah, it'd be 745 or something.
Yeah, it's a lot more. And so I think like right now I know we're the top contributor. But then people make open source hardware based off our stuff too. So it's an ecosystem. It's good. So we're really pleased to see the certifications going. You're doing hardware and you just want to send the signal out that you really did open source hardware. There is a certification process you can do. It's super easy. We do it. And for the folks that are going to the summit, have fun.
Yeah. I think it's in Canada.
Yeah. So next up, we have our Adafruit learning system guides. What's on the big board this week? Speaking of open source hardware.
Okay, we actually had a lot of updates, a lot of these like Raspberry Pi robot updates. So we've been doing a lot of testing to make sure that all of our stuff works with the latest version of Bookworm and the Raspberry Pi 5. So you'll see a lot of updated guides. Liz also did a new guide for the TCRT photo reflective interrupt sensor. Thanks, Liz. It's a simple sensor, but still needs a guide. And we also have... Yeah, go ahead. And also a guide for the LTC 4316 address translator. And I think last week we had the watch winder and the IoT batteries. So
yeah, we had that.
a lot of people working on projects. They come in little bursts. You'll see a couple projects get published in the next week or two.
Okay, cool. Let's take a quick break and do some factory footage. All right, next up. So for 3D printing this week, we just have a speed up and then we're going to roll right into Ion NPI. So Noah Pedro, take it away.
Room it away.
Okay, don't forget the code is Springy. Let's do some. Brought to you by DigiKey. This week is Rich Tech, your power partner.
Partner.
Hey, Data, what is the INMPI, the new product introduction of the week this week?
Okay, to no one's surprise, it's a power chip from Rich Tech. They're really good at making power chips. So this week it's the RT6160A. Which looks like this. It's a very small chip with, BGA mounting is designed to be very small. But don't let the size fool you. This is a very powerful chip. So it's a very interesting and very useful um, kind of all-in-one power supply management chip that you could use for especially something wearable that uses batteries. It's a 3 amp output buck boost converter, which is like a massive amount of current. Or sorry, the switch I think is probably 3 amps, which means still you can get an amp of load or more. And it's a buck boost, which means it runs from as little as 2.2 to 5.5 volts. And then the output can be kind of anywhere between 2 and 5 volts also. Say like 2.8, 3, 3.3, 3.5 volts are all valid. And you can use the I2C interface. It has to configure the voltage output. So you can dynamically change it. You don't have to use resistors to fix the voltage. If you want, you could start running your code at 3.3 volts and then you can drop it down to 2.8 later. Yeah, it does have up to 3 amps of output current. Especially in buck mode, it's going to do great for that. Boost mode, it's 2.5 amps max, but still a huge amount of current. And an amazingly low quiescent current of 1 microamp non-switching, and I think another 1 or 2, like 2 microamps total typical quiescent current, which is like unbelievably low. Even most LDOs don't go really below like 10 microamps. So, amazingly low quiescent current, high current and high efficiency output, and it's configurable over I2C. So it kind of does everything you need in a power supply chip. Um, you know, a lot of people ask me like, when would you use a buck boost converter versus an LDO? And I use LDOs all the time. And in particular, I use the RT9080 a lot, which I'll show in a second, which is a LDO from Rich Tech. And the LDO stands for low dropout because basically you have the input on the left, and they have this power MOSFET that you kind of turn on and off, with this op amp circuit in the middle. And you basically, tweak the amount of voltage on the FET until the output is the voltage you want. So V in always has to be above V out. So you can have 5 volts in and you can have 3.3 volts out. But then all that current in between is burned off as heat. Like that 1.7 volt difference, you have to dissipate that out. And so it's good for like, low current, low efficiency, because you maybe don't care, you're running on a battery and you don't want to have the space or the expense of a buck boost converter. As long as the V in is pretty close to the V out, maybe the dropout is so minimal, maybe it's still within 90% efficiency and low noise. Like I mentioned, that I really like the RT9080. This is like a go-to LDO for our low-cost boards where we don't have a buck or a boost converter. And what's nice about this board is it's got, again, very low quiescent current, like 5 microamps or less, which means on this itsy bitsy ESP32 here, if you look on the left, you can see in deep sleep mode, the ESP32 is, maybe 5 to 7 microamps, and the LDO is 3 microamps. It's just like unbelievably low current compared to like other chips which we use, like the AP2112, which has like 50 microamps of current, which just makes a big difference. It's like basically means you get 5 times as much runtime in deep sleep as you would. So a lot of people, when they're designing wearable or portable projects, they're going to be powering stuff off of a oh, sorry, I can move to the, this is loud.
That goes in.
Yeah, sorry. I just want to make sure we don't skip ahead. They're usually running off of a lithium polymer battery. So the lithium polymer battery, they're called 3.7 volts, but really, they have a nominal of 3.7, but they start at 4.2. It depends a little bit on the temperature as well and the drainage. So here, C here is the drain rate. So assuming you have a low drain rate, 0.2 of, if it's a 1000 milliamp hour, that means you're 0.2 times the milliamp hour in milliamps is the rate. So if you're drawing like 200 or 100 milliamps or less on average, you start at 4.2, which is well above 3.3 volts where you normally use it. But then as you kind of drain more current, especially high current, the voltage droops quite quickly, and then you very fast get close to 3.3 volts or even below. And so you see, even, especially if you're doing spikes of current because you have like a radio or you have a motor, you can quickly have the voltage of the battery dip below your 3.3 volts nominal voltage. It'll go down to 3.1 or 3, but there's still plenty of capacity and current inside. So you want to use something like a buck boost. So when the voltage of the battery is above 3.3 volts, you'll buck it down and you use an efficient buck converter so you're not losing any of that dropout voltage. And then if it's below 3.3, you'll boost it up. And a really nice design, as you see here, it's all inclusive. So you'll need one inductor. It's a generic example. You need one inductor, input capacitance, output capacitance, and then a resistor divider to set the output voltage. These chips tend to be more expensive than just a buck or a boost, and they, oftentimes have a little bit more complexity. But what I really like about the RT6160 is how simple it is. Like this application, usage schematic, it's like you really just need an inductor. It needs to be a big inductor. You need input capacitance, output capacitance, and you don't need a resistor divider because the default output is 3.3 volts. And then you have, a couple GPIO lines for I squared C configuration, enable, and signal. The signal is what determines, I'll show you later, there's two voltages you can switch between. And of course, enable takes it into low power mode. So not a lot of pins, not like, there's no like strapping capacitors and like feed forward, da, 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 da. And then compare it to the TPS series. The quiescent current here is 2 to 5 microamps compared to 15 to 25. So for deep sleep, it's going to make a really big difference. Okay, and then it is a BGA, it's a WLCSP. It's very small. This is designed for like obviously like very tiny circuits. I can definitely see it being used for audio circuits where sometimes like I said, motors, radios, where you sometimes need to connect over Wi-Fi. You have a burst of 500 milliamps or 1 amp of current, but otherwise it's going to be very low current sipping, and you want to maximize that battery because by using a buck boost with this low quiescent, and I'll show you the configurable battery, you can really like get that last 5-10% of battery life out without harming the battery, but keeping your circuitry running. One thing just to note is, it's not a wide range input output. It is, basically 2 to 5 volts in, 2 to 5 volts out. The output current is 3 amps, which is a lot. Just, make sure that your battery supports that. That's a huge amount of current, especially if you're boosting it. I think of the boost, like I said, it's 2.5 amp. That's still a lot. That could be sucking 4 amps out of your battery. So obviously if you use this for RC circuitry, but a small battery won't be able to provide that. You need, one of those like 18650 or something batteries. Okay. Next up, I squared C is really simple. There's a couple stats, there's a device you can read, and then there's a V out 1 and V out 2 register. I think these are all 16 bits wide. And so you can set the output. You're like, why is there two outputs? Because you actually will switch between them, which makes sense. Because usually you would set this up to have like 2.8 volts and 3.3 volts, and then use a GPIO to like immediately switch between the two voltages. This means that when you want to go into a different mode, you don't have to send the I squared C signal over and over again. You just switch back and forth. So when you're doing the radio or you're doing the motor, you can go back up to 3.3 volts, or 3.5 or 4 volts. And then when you're not using this like high voltage, high power peripheral, you bring it back down. And then if you have a microcontroller that has clock, you can PLL adjust the clock. Combine that, you could have your microcontroller running as little as 2.5 or 2.3 volts. And at a lower frequency, you can save a ton of current while still keeping your microcontroller running. So a lot of power savings can be squeezed out by using this chip. Here's the layout. One thing I like is it is a BGA, but at least you don't have to like get signal out from the middle. You can use this. I mean, they have a 4-layer board here, but it's not a bonkers 4-layer board. Like you're not using any doesn't look like you need any bird vias for it. Well, of course you can. And then there's an eval board available, so ready to go. Input, output, and all the configurations on little test clip leads. So if you want to get started, all this stuff is in stock at DigiKey.
That's right.
And for a good price. It's like less than $1.50 in quantity. It's amazing for a buck boost converter, 3 amp output.
Okay. And that is Ion of Chapter.
On NPI.
Okay, don't forget to code Springy. 10% off Native Restore and get all that free stuff too. Okay, let's go over to new products. First up.
First up, we have the CuteBot Pro. So I think we have the original CuteBot. So this one is kind of like the same thing. You plug a microbit in, you get motors and sensors, and there's a sonar for distance and 2 wheels. The big update with this one is you can now use an 18650 battery, which we do not stock, but you can get them on various online sellers or sometimes I think in some hobbyist shops. And you can then use it as a rechargeable battery pack, so you don't need an external battery pack. So we're starting this for the people who are comfortable and okay with getting this other external battery and plugging it in, keeping in mind that we do not sell that battery ourselves. Next up, we have some ESD plastic tip tweezers. So these are plastic tips, so just be aware that they're not for hot air rework and don't get your soldering iron tip too close to them. But they're ESD safe and they have like these soft replaceable tips, which some people might like. So good for picking up components. You can show them really fast on the overhead, maybe. Oops, hold on. Just got tweaked. So this is my pair. It got a little bit melted and damaged because I was experimenting. Like, what happens if you do heat it? Turns out you can't. But these are nice and delicate, so they're good for dealing with components where you don't want metal tips for some reasons, and you don't want to the possibility of scraping or scratching them.
Okay.
Next up, we have a new BFF for Xiao and Cutie Pie boards. This one features the BNO055 9 DOF sensor plus the BMP 280. So it's a 2 for, it's like 10 or 11 DOF, I guess. What's nice about the BNO055, as you see here, it will just give you quaternion or Euler, this is Euler angles out immediately. You do not have to do any fusion. You do not have to keep track of your error. You don't have to do your magnetometer calibration. It does it all for you, which makes it a little bit more expensive, but means you can use any processor, which is great. People really like that for robotics and motion detection. The second thing is the BMP 280 on there is a barometric pressure sensor. And you're like, well, what does that have to do with the 9 DOF? Well, you can use the barometric pressure sensor for altitude detection. So you can not only tell the X, Y, and Z coordination in space, but also how high up you are. If you pair this with a GPS, now you can like pretty much identify anything perfectly within the confines of Earth's atmosphere, which would be kind of cool. And it's a little BFF board, so you can just plug it right into the back of your Cutie Pie, or you can solder it directly onto the back if you like. It's got little castellated pads even. But we like to use little skinny stacking headers to make it a nice compact package. But a lot of people want to do motion, or maybe you want to make the tiniest little drone. This would be great for that.
Next up.
Okay, next up we have the TSSP 77038. The 038 stands for 38 kilohertz demodulator. Okay, so this is an interesting chip because a lot of people are like, oh, it's an IR remote receiver. Yeah, it is, but it actually does a little bit more than that and a little bit less than that. So we're going to show off our IR receiver in a bit. But what a demodulator does, it doesn't have any brains. Like IR receiver chips usually look for and try to understand whether it's an IR remote signal, and they only pass valid IR signals from like a remote control. This doesn't do that kind of filtering. It will pass, anytime it sees any 38 kilohertz infrared signal at like 940 nanometers, it passes the demodulated signal along. Why would you want to use this? Well, IR remotes, like I said, you can't send a continuous signal of IR remote on an IR remote. Like here you have to like stop and you send it again and you see little blips. If you want to use a break beam sensor that is modulated so it's not as affected by ambient light, if you want to do a proximity sensor that bounces modulated IR light, this is more for that kind of experimentation with modulated IR light. You could use this with a remote control, but honestly, I don't recommend it. I recommend getting an IR remote receiver instead, because that'll actually do like the demodulation for you, but and filtering for you. This is more for like science experimentation, where you want to mess with IR light.
Okay, and the star of the show tonight, besides you, Lady Ada, our team, our customers, everybody who makes this community go is
Dun, 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 the IR receiver board. So that goes along with the IR demodulator. This board is specifically designed for people who want to do infrared remote projects. You can see, like, you press a button and it's like, I've received this code. So we sell in the store like little breadboard friendly infrared receivers. The problem is that you can't mount them easily, and you have these like little thin legs that you then have to solder wires to. What's great about this is that you can plug in a 2 millimeter JST connector, and then you can plug into a board, and you can see there's like the wiring is very simple. Another thing that's nice is there's a little red signal indicator LED to let you know that it's received signal, and there's 2 receivers on there you can select between, depending on whether you want horizontal or vertical coverage. So if you go to the overhead, I have a prototype here. It's green, but otherwise it's the same chip. So the first thing is, oh, that's really bright. So let me pop that. 1 moment. Okay. First off, there's 2 receivers. There's a vertical and a horizontal. And that's because maybe you want to have something that's like edge mounted and you want to have it pointing out, or something flat against the wall, and you want the signal to have as much coverage on the horizontal plane. So between these 2, you get, you obviously don't get coverage on the back, although this one does have a little notch, and like this is translucent, so you probably could get some signal even if it was coming from the back. There's a switch to select which one you want to use. You can't connect them together because if they have differing signals, they will fight each other. And so you have to select which one you prefer. But on the final version, if you go to this photo, I apologize, I mean this one. On the back, you see that it says IRH, IRV. If you want, you can get the individual signals from each one. If you have 2 infrared inputs on your microcontroller, as well as the signal, which is the selected output. And then, okay, so can you go to the overhead again? I forgot how to prototype. And then, another nice thing, let's make this less bright, is you can see when you send messages, the signal LED goes off, lets you know it was received. And then I just have a little example code here.
What's the max distance for IR?
I'd say up to 25 meters if you're lucky. It kind of actually depends on the transmitter, not the receiver, right? The receiver will, any signal you get, it'll work. This will probably work about 10 meters away at the most, maybe like, it's best before 10 feet. It's meant to be like a room remote. But we have an IR transmitter dongle that we sell. And it's very high power. And if you use it, yeah, you'll definitely get like 100 feet plus, no problem. Okay, so this one, as we press each code is being decoded, and it's like telling you do have to, the output is the demodulated signal. It has to go into a microcontroller that has an infrared receiver. So in this case, I'm using CircuitPython. Arduino also has IR receiving. Just make sure that you use the right pin and the right library. You have to decode it. Like, this is an NEC remote. So this board doesn't do any of that, like, oh, I've decoded it to also tell you what the protocol is. It just sends the bit stream out, and then your microcontroller or microcomputer will have to actually convert that into which code and which button was pressed.
All right, and that is new product.
New.
All right, don't forget, you can get some of the stuff here. Springy's code. We're going to answer questions. I have some lined up, but first we're going to do some top secret.
Okay. Ooh, it's in the vault.
Trinity 1.
Okay, so we got some more Trinkies being designed. So this one was a request from Bill Binko at 18 Makers. So this is a TRS Trinky. And the thing that he wanted was basically a USB adapter that would connect to a TRS 3.5 millimeter audio jack, but did not have one pin connected to ground or power. It's like every pad on the audio connector was a GPIO or analog input, because this connector format is used for different accessibility tools and they have different pinouts. And so you want to be able to like dynamically decide based on the code, which is the input pin, which is the output pin, which one's grounded, which one's power. So I just, it's got a SAMD21 and a NeoPixel, and then, every pin on that TRS plus the 2 switches again goes to different GPIO, and then you can read them all. And then to make it mechanically stable, it's got a USB-A through-hole connector. And then we're looking at this like cool Windows 10 HID RGB LED array like protocol that they've come up with. And we're like, oh, it's basically like NeoPixels. So it'd be cool to have like a USB HID to NeoPixel converter. So it's still pixel trinky. That you could use also with, Python, or, you can program in Arduino. It could be standalone running. And it just gets 5 volts. There's a level shifter, and it can control 2 strands of two strands of NeoPixels, or 1 strand of dot stars, because those use 2 pins. And the SAMD21, like, you think of it as a small chip, but it's got 32K of RAM. In Arduino, you can drive like 10,000 LEDs if you wanted to. So maybe we'll make a little USB interface code so you can like write pixel data from any application, and we'll just like pipe it out very easily. And then finally, a lot of people are like, hey, can you make some of these Trinkies in USB-C? But I'd have to find a plug that's USB-C, like that's a USB-C plug, and also mechanically stable, like the USB-A plug. So I kind of made a breakout. Hopefully this connector that we found on the great search last week, so watch that video, will work, and it'll be mechanically stable, and we'll be able to use it to make some USB-C Trinkies.
That's top secret.
Yeah. It is.
Okay, we're gonna roll right into questions, and then we are going to bounce to try to get out of here a little
Yeah.
tonight.
Thanks, everybody.
Yeah. All
Okay.
right. So, question, Lady Ada. The first one is, you did the max distance for IR.
Yep.
Could you compare the floppy disk archiver and the emulator prototype with the release Adafruit floppy Featherwing with 34-pin IDC connector?
The floppy featherwing is kind of like a very simple board that's just, you can run any code on it, but it doesn't have buttons and a TFT. It doesn't have it doesn't have a level shifter. It can't emulate because it's set up for only writing to a disk drive. But it's basically for like floppy experimentation, whereas the Flopsy board is kind of an all-in-one. You can do anything with it. It's like a multi-tool for floppy.
Okay. Next up, is it possible to keep a lithium-ion battery the same size but make the milliamp hours bigger or larger?
You can, well, by the clever use of chemistry. One thing you can do is, depending on the anode chemistry, you can have it be a 4.3 volt or 4.4 volt battery. I think they get up to, depending on the chemistry used, and that will just give you more voltage. So then, when you buck it down using the RT6160A, you'll get a little bit more capability. In general, it depends on just the quality of the battery. Like some, batteries are high density, tend to be the 18650 size, because that's kind of where like a lot of the technology is happening, because those are used for making battery packs for like scooters and cars and every other kind of electric bicycles and all that good stuff. So there is sometimes variation based on the size, but not for live polys as much. Those are kind of like, the size is very much related to the capacity.
Okay. And let me see if there's any more, because we had them lined up, but I think that might be it.
Okay.
Thanks for helping us get out early tonight.
Thanks, everybody.
I
Yeah.
think that is it.
We still got a lot done.
Yeah, we did.
Oh.
There is. That's how we're getting stuff done. We're cloning ourselves. So we'll see everybody next week. Thanks so much. Don't forget the code is Springy.
Okay.
This has been an Adafruit production.
We're doing it.
It is your moment of Zener.
Bye, everybody.
Bye.